All right, let's go through the announcements. All right, so homework 5, I put on my classes that'll be due next Thursday. Quiz 4 is today, so topics, line of best fit, correlation, stuff like that. And I guess we have a test next week. So Friday will be our first test. And I guess that reminds me to pass out the test review for next week. Okay, so let's see. The very first page is just a list of topics. So anything that's game for the test. Basically, some people just like to kind of check off a list of different topics that they know or don't know. So I just decided to put a little list of topics. And all right, so going down, we have a practice exam. Just a little disclaimer, the practice test is a little bit longer than the exam next Friday. So don't freak out if there's like too much stuff on it. There you go. Yeah. But it's just for you to practice. What I'll do here is I'll give you some time to take it maybe over the weekend or something. And I'll post the answers on my classes by like, I don't know, Wednesday or Tuesday, something like that. So you can check your answers and make sure that you're on the right track with these questions. All right, so any questions on the test review or the quiz or the homework? Yeah.
Can we do like a practice problem for like,
Yeah, so do you have a specific topic in mind?
yeah.
Yeah, how about this? I'll share my screen.
Yeah, just take a problem like number 2.
Like number 2, okay. Yeah. Yeah, but then like plugging in the equation gets a little tricky, right? So how about this? I'm going to go to the end of these notes, start a blank page, okay? And this is just something like number 2 on the quiz review, okay? So number 2, quiz. Okay, quiz, okay. Trying to think of a good idea of things that are correlated. How about, I don't know, the amount of water that dogs drink and the amount of time that they ran outside. How about that? So how about this? Let X represent the amount of water a dog drinks. And let's say Y represents the amount of time a dog spends outside. Okay, so maybe we think there's a correlation between these two. And let's say we collected some data outside and we made this line of best fit. And I'm just going to make this up. Trying to think of something that actually would make sense. Maybe like 6 plus, no. How about 3 plus 2x? I don't know. We'll see if that actually makes sense, but that's what I'll say. Okay. And how about let's make it a little more complicated. Let's do 0.2x or something. Okay. Okay. And let's make this one a decimal. Oh, that's 3.5 plus 0.2x. There we go. Something more realistic. Okay. So how about this? One of the questions I can ask you is, how about this? Predict the amount of time spent outside. Maybe for a dog that drinks, I don't know, maybe 3, I don't know, milliliters, I don't know, of water. Okay, so when I do these questions, and we're asked to predict something, I like to make a table of like the X and Y values just so I know exactly what I'm plugging in, okay? So we have X equals and Y equals. So we're given 3. Do you think that's an X value or a Y value? X value, right? Because X is the amount of water a dog drinks and 3 is the amount of water you drink, right? So that has to be X. And that means we're solving for Y, right? Okay, so Y equals 3.5 plus 0.2X. And I guess we're just plugging in for X, right? Y equals 3.5 plus 0.2 times 3, right? And let me get my calculator out. 0.2 times 3 ends up being 0.6. So 3.5 plus 0.6. And when we do that addition, we get Y equals 4.1. Okay. So does that, this particular question make sense? Okay, let's go the other way. Okay, so how about part B? Let's do the opposite direction. So let's say a dog spends, I don't know, 5 hours outside. Okay, how much did he drink? Or do we predict that he drank, right? Okay, well, X and Y. Do you think 5 is the Y value or the X value? The Y value, good, because Y is the amount of time we spend outside, right? And that means we're solving for X. So writing our equation, I guess we have to plug in for Y. 5 equals 3.5 plus 0.2X. Okay. What's my first step to get X by itself? Good, subtract 3.5. Okay, so on the left, I'm getting 5 minus 3.5, which is 1.5. And on the right, I'm getting 0.2X. How do I get X by itself? Divide, good. So divide by 0.2. 1.5 divided by 0.2 is 7.5. So I've isolated X. The amount of water the dog drank was 7.5. So any questions on like the last part of the quiz review? Are we good for questions like this on the quiz? Nice, nice. Okay, so why don't we do this? I forget where in the world our notes are. Oh, here. There we go. Okay. And before I go on, is there anyone who needs the guided notes from last class? Anyone else? Yes.
I know, yeah, this number would be 1.
Oh my goodness, I meant to put measurement as the
Oh,
term.
okay.
Okay. Okay, so on the test review for number 2, part B says qualitative outside of the parentheses. That should say measurement. Yeah, I don't need a typo there. Thanks for catching that. Okay, I'll make a note of that. So number 2, part B says, or like answer choice B says qualitative before the parentheses. I want you to change that to say measurement.
Right here.
Yes. Yes. I'm sorry about that. I kind of wrote this up last night.
Are you gonna have like any like study sessions where we can like go through this?
I don't know if I'll have study sessions for the review. You can, of course, go to my office hours, but we'll do a review on Wednesday.
Okay.
Yeah. Yeah, if you have any questions about the test topic, like practice exam or anything, definitely come to my office and we can go through any questions. All right, let's see. Chapter 27. We started this section on probability. I like to call it chance and uncertainty because we're talking about things that might happen, but they also might not happen, right? We had this way of organizing different types of ways to describe the probabilities of things. And it kind of let us know that probability isn't just like random numbers. It's actually a spectrum of different things, right? For example, quite likely is different than, I don't know, Buckley's chance, right? So we had the difference between those two words. We talked about how we can talk about the probability. So for example, we can write the probability of heads, right, is equal to 0.5. So we can represent probability using decimals, fractions, percents, and we have a special way to write our notation, okay? We talked about these things called random variables, which are just things that we're interested in the probability of. And in particular, random variables are numerical, so we describe them using numbers. There's different types of them, discrete, continuous, and we talked about the difference between those two, okay? So what we're gonna do here is talk about a new term in probability, okay? And this term is called the sample space. So let's just pretend I'm doing an experiment. For example, flipping a coin a bunch of times, or rolling a dice a bunch of times, or I don't know, I had a big bag of marbles and I'm pulling marbles out and putting them back in, stuff like that. And that's what we call an experiment, okay? And an outcome of the experiment is like the number that I pick up, or the, I don't know, the number on the die after I roll it, or the heads or tails that I get when I flip a coin, right? All of the outcomes, if we like compile every single possible outcome that can ever happen, we call that the sample space, okay? So sample space is the set of all of the possible outcomes of an experiment, okay? If that doesn't make sense, let's take a look at an example, okay? So here's one example. We're tossing one die. A die has 6 sides, right? Okay. What sort of answers or what sort of outcomes can I get when I toss a die? Yeah. Awesome, right? We can get 1, 2, 3, 4, 5, 6. We can't get like 10 or like 13 or anything. So let's see. Let's just write out all of our possible answers. 1, 2, 3, 4, 5, 6. Okay. These are all the possible outcomes I can get, right? Can't get anything else than that. Okay. And when it's talking about the set of all possible outcomes, I'm going to do this. Looks kind of funky. I'm going to put it in brackets. Okay. And now I've made what we call a set of numbers. Okay. Okay. So I literally just took all the outcomes and then I put it in brackets, and now it's the set of all possible outcomes. Any questions on the sample space? How would I find the probability of getting a 2? 1 out of 6, right? So let's kind of talk about that. Well, I guess there's 6 possible outcomes here, right? So this is the amount of outcomes. And then all of the outcomes have equal probability, right? So 2 just represents one of the possible outcomes, right? So this is like the one of the outcomes. And it's only one because there are, everything has an equal chance of getting chosen, right? So every outcome is equally maybe likely, right? You can't get a 2 more than you get a 6. Mm-hmm.
So say the dice had like a misprint and there was 2 2s, would then it be would it then be 2 out of 6 as a chance?
Yeah. Mm-hmm. So let's just let me put that. That's a really good question, actually. So let's just say we have a die or dice, I don't know, a die that has 6 sides that look like this, like 1, 2, 2, 4, 5, 6, right? Okay, so let's just imagine that possibility. Our sample space is still going to be, well, 1, 2, 4, 5, 6, right? There's only those outcomes. There's no 3 and there's a 2. We don't really count it twice if there's a 2, but the probability isn't as easy as putting 1 over the amount of things that happen, right? Here, 2 happens more than once, right? So I guess there's 1, 2, 3, 4, 5, 6 things that can happen like individually, right? But the probability is now 2/6 of getting a 2, right? Which is 1/3. Okay, so this is an alternate scenario. Okay, that's a really good question, and we'll kind of get to those types of questions a little bit later. But for now, this is kind of a situation where everything's equally likely. It's pretty easy to find the probability of rolling a die, right? Okay. Okay. Example 2, tossing a coin. What do you think my sample space is? Heads or tails? Good. I'm just going to write this HT and put it in brackets, right? So this is my set of everything that can happen, right? Okay, what's the probability of obtaining heads? Half, right? Everything's equally likely here, so it's pretty easy to find the probability, right? Everything equally likely. Okay. So let's take a look at example 3 now. Let's say I'm part of this polling company and I've called like 300 people at random. So I basically just called a bunch of people, asked them who would they like to vote for, or oh, would you vote for a new school bond? There we go. Okay. So I guess our answers could be yes, no, and I'm not sure, right? So 123 said yes, 134 said no, and 43 said not sure, right? And it says that all outcomes are equally likely since the people were selected at random. I think I kind of said that a little bit weird. I'm just saying, like, every time you call someone, you're not really sure what they're going to say, right? Okay. How about this? For now, let's just kind of cross out this because I feel like it gets a little confusing. Okay, let's just cross out that sentence that all outcomes are equally likely because I feel like it's going to get a little confusing when we talk about probabilities. Okay. Let's talk about the sample space first. Okay, sample space. Okay, what is our sample space? Awesome, awesome. All the possible things that can happen. Yes, no, or not sure, undecided. Okay. So sample space is pretty easy. You just write down everything that can happen. Okay. Now, let's take a look at this. Our sample space has 3 things, but that's not telling us that the probability of a yes is 1/3, right? How do you think we should find our probability of yes? Awesome, right? So 123 is the amount of yeses, right? And 300 is the total of people that I've called, right? So total number of people. Okay, so here it's not like every single thing in the sample space is equally likely. This is very similar to our die that like has different sides to them, right? That we have different probabilities for yes, no, and undecided here. Okay. So any questions on finding the sample space or finding like probability when we're kind of given a lot of information about like each of the answers? Yeah.
So you do that for all of them, like yes, no, and then decided?
Oh, yeah, we could definitely do that, right? So we could find the probability of no, right? And that would be what, 134/300, right? We could also find the probability of undecided, which is 43/300, right? So we have different ways of presenting probabilities. We are actually going to go into a place where we're not just like finding the probability of one outcome. We're going to find the probability of all the outcomes and stick them into a chart. Okay, so that's where we're headed. So the chart's name that I'm talking about right now, we call this a probability distribution. Okay, so we already know what probability means, right? And distribution is, oh yeah,
Sorry.
no. You're fine.
For the example number 3, you don't want us to like simplify it, just leave it over 300. That's
Oh, no. You could definitely simplify it. I just didn't do it with my calculator.
no, that's fine. I
Um,
just wanna make sure.
Yeah, so I guess this would be, I don't know if you can simplify it, but maybe 0.41, right? Okay, this would be, I don't know, 134 over 400, sorry, 4 divided by 300, 0.446, right? Right. So you can represent things in decimals, fractions. Actually, it's a good thing you brought that up because a lot of times people present probability using percents. You can, but usually we use fractions and decimals, okay? So fractions, decimals, sometimes percents, okay, but not really, okay? And we'll kind of talk about that a little bit more, why we don't use percents. Okay. Let's go back to the probability distribution, right? Know what probability is? Distribution is like where we distribute things, where we can organize things in charts and graphs, things like that. And we're actually going to just focus on the discrete random variable. So does anyone remember what a discrete random variable is? What was the opposite of discrete? Continuous, right? So discrete was the thing that you could describe using whole numbers, right? So 1, 2, 3, 4, 5. Continuous things can be described using fractions and decimals. Did you have a question, DJ? Ah. Okay, so that's what we mean by discrete, right? And this specifies the probability for every possible value. So everything in the sample space, and that we list everything in the sample space, and then we write the probability like underneath it, right? Okay, so there are some things that you should know about a probability distribution, okay? There are 2 properties that these distributions have to hold, okay? The first one, I like this color, okay? I'm gonna write something kind of weird, but bear with me, okay? 0 is less than or equal to, P of X is less than or equal to 1 for every value of X. Now let's talk about what that means. Lots of stuff going around. Okay, we know that X's are the things that can happen. These are the outcomes, right? So rolling a die and getting a 2 or flipping a tails, right? These are values of X, they're inputs. And P of X is the probability of X, right? Okay, so let's just read that. The probability of X is greater than or equal to 0 and less than or equal to 1, right? So I guess what this is saying is the probabilities can't be negative or bigger than 1. Now we kind of touched on that on Wednesday, right? We said probabilities can't be like 5 or 15 or negative 300, right? They have to be between 0 and 1, okay? So that's what property number 1 says. Okay, let's go to property 2. Okay, here's the second thing. The sum of all the probabilities must add up to 1. Let's kind of think about what this one says. Well, a probability distribution takes everything in the sample space that says everything that can happen, right? And we have different probabilities for everything, right? So like heads is 0.5, tails is 0.5. Now, I guess everything put together is like every possible thing, right? So I guess if we kind of add everything up or ask ourselves, what's the probability of everything happening? It has to be 100%, right? There can't be like 98% chance of everything possibly happening, right? So the sum of everything in this distribution, all the probabilities, has to add up to 1, okay? Okay, so very important here. to be a probability distribution. Okay, the chart has to satisfy both the properties, okay? The chart must satisfy both rules, okay? And what I mean by that is, I guess you can't break one rule, okay? Let me even write this. Can't break one rule. Okay, so even if all the probabilities are between 0 and 1, if they don't add up to 1, then it's not a probability distribution, okay? Or if they add up to 1 and there's like a negative probability, it's not a probability distribution, okay? If that doesn't make sense, I think the examples will kind of show us exactly what we mean by this, okay? So how about this? Take a look at example 4. Okay, here's our probability distribution. We have all our x values. So these are the outcomes. Maybe you were rolling a die that has 4 sides, okay? 1, 2, 3, 4. And underneath here are all the probabilities. So for example, the probability of 2 is 0.65. And the probability of 4 is 0.11. Okay. Okay, who thinks this is a probability distribution? Okay, raise your hand if you don't think it's a probability distribution. Anyone want to explain?
Because the probability for 3 is negative number.
Good, good. So you notice the probability of 3 is negative 0.3. What property does that not hold? What property goes? The first one, right? So how about this? No, not a probability distribution. And our reasoning for this is, well, it didn't satisfy property 1. Right? Okay, it didn't satisfy property 1. Do we need to go and check to see if it satisfies property 2? No, right? Because it already broke a rule. We don't need to go and check property 2 now because we already know that it doesn't satisfy the first property. Okay, so no need to check property 2. Okay, didn't satisfy property 1, we're done. Okay, let's take a look at example number 5. Okay, well, here we have negative x values. Okay, so maybe one of our outcomes is getting a negative 1, negative 0.5, 0.51. Well, it's kind of hard to see if this satisfies the probability distribution right now, because all the probabilities seem to be okay. So how about this? We're gonna check each property. Let's do property 1. Okay. Who thinks this satisfies property 1? A hand. Why do you think it satisfies property 1? Yep, all the probabilities are between 0. Now, there are some x values that are below 0, right? But that doesn't matter. All we care about are the probabilities for the whole row. Okay, so all the probabilities are between 0 and 1. So we're good. Okay, this negative 1 and the negative 0.5, totally okay. Okay, let's check property 2. How do we even go about checking that?
Just add all the bottom probabilities up and add.
Yes, right? You add all the bottom ones. So 0.17 plus 0.25 plus 0.31 plus 0.22 plus 0.05. Okay, and you can calculate that you want, but I got 1 when I added them up. Okay, so satisfy property 2 or not satisfy? Satisfy, good. Okay, so we satisfied the 2 properties. So I guess this is a probability distribution, right? So yes, this is a probability distribution. Explanation point. Okay.
So, if you have a question like this on, the course, you have to explain just like.
I would say definitely, yeah, I would definitely be like, okay, checking one, checking two, yes, right? I feel like my question would be more, where we like, is this a probability distribution? Why or why not, right? Then you have to explain why it is, right? Any questions on example 5? All right, example 6. Okay, let's do the same thing. Let's check our first property. Does this probability distribution satisfy the first property? Ooh. Yeah, right. Everything's between 0 and -1, right? So yes, all the probabilities, probs, are between 0 and 1. Check. Okay. Checking 2 would be adding all of these together, right? 0, 0.3, 0.1, right? Let's do that. 0.3 plus 0.31 plus 0.90 plus 0.43. And I got 1.94. Okay. So do we satisfy property 2? No, right? And is this a probability distribution or not a probability distribution? No, right? Not a probability distribution. Okay. So does anyone have any questions in determining if something's a probability distribution? Seeing if it's not a probability distribution, something like that. All right. Let's flip our page over, okay? So now that we know what a probability distribution is, we know like what it means, how to read it, and to determine if it is or not. I think a good example would be to actually make one, right? How do we actually create these guys? Okay. So we have a probability distribution of the following. We have a die and it's loaded. Okay, so does anyone know what a loaded die is?
It's like weighted so that one side is more likely to get rolled.
Yeah, like it has little weights in it on like different parts of the die. So like it might be more likely to roll a 2 or roll a 6. Okay. Some people like bring those die into like casinos and try to win that way. So this die is loaded in such a way such that the probabilities of getting 1, 2, 3, 4, 5, and 6 are 1/2, 1/6, 1/12, 1/12, 1/12, 1/12. Okay. So if we're trying to make our probability distribution, let's see, what would go in the X row?
1, 2, 3, 4, 5, 6.
Yeah, right, because these are all the outcomes, right? 1, 2, 3, 4, 5, and 6. Does everyone see how the X values kind of take on all the values? Okay. And then I guess the probability of X are their probabilities, right? What's the probability of 1? 1/2, good. The respectively word just means that like 1 is 1/2, 2 is 1/6, 3 is 1/12, and so on. So 1/2, 1/6, 1/12, 1/12, 1/12, and 1/12, and we're done. So that's all you do for these 6 questions. All right. How about this? Let's do one more. Okay. This one's a little bit more tricky. Also, I think my boxes are messed up here, which is fine, but it's okay. How about this? We have a box and it contains 3 $1 bills, 2 $5 bills, 1 $10 bill, and 1 $20 bill. What would go in the X row here? Amount of money, right? So I guess what would go in the first box? 1, good. The second one, 5, 10, and 20, right? Okay, I'm very sorry I didn't make the boxes right. So maybe just scratch out the last 4 boxes. Okay. And then over here, we're gonna write the probability of a 1, 5, 10, $20 bill, okay? How would I find the probability of a $1 bill? Let's do Emma.
Okay, I was just gonna say, just add up the total amount of bills, so
Mhm.
3 to 2 to 1, and then
Uh-huh.
divide the amount of that bill by the total.
Nice, nice, nice. So we have 3 $1 bills, 2 $5 bills, 1 $10 bill, and 1 $20 bill, right? So in total, not really thinking about the amount of money, we have 5, 6, 7 bills, right? In total, right? That's the amount of bills that are in the box, right? Okay. So Emma said to put 7 on the bottom, and what would go on top? 3, right? Because there's 3 $1 bills out of the 7 that are there. Does that make sense? Okay. So this would be 3 out of 7. What do you think the probability of 5 is? Good. 2 out of 7, 10, 1 out of 7, and 20. Awesome. Okay. So example 7 is a little bit more tricky because we have to find the probabilities. But when you list the X first, it becomes really easy to like count the total amount of things that there are, right? Any questions on example 7 and example 7? Right. Well, I think that's it for this packet of guided notes. So I think what I'll do is I'll start the quiz a little bit early